Welcome to our channel. Today we learn Generative AI Basics. What is Generative AI? Generative AI is a type of artificial intelligence technology that can produce various types of content, including text, imagery, audio, and synthetic data. The recent buzz around generative AI has been driven by the simplicity of new user interfaces for creating high-quality text, graphics, and videos in a matter of seconds. Difference between discriminative AI and generative AI. Discriminative AI. Learn the hard or soft boundary between classes, providing classification splits, probabilistic or non-probabilistic manner. Allow you to classify points, without providing a model of how the points are actually generated. Don't have generative properties. Make few assumptions of the model structure. Less tied to a particular structure. Better performance with lots of example data. Higher accuracy, which mostly leads to better learning result. Discriminative models can yield superior performance, in part because they have fewer variables to compute. Saves calculation resource. Can outperform generative if assumptions are not satisfied. Real world is messy and assumptions are rarely perfectly satisfied. Not designed to use unlabeled data, are inherently supervised and cannot easily support unsupervised learning. Do not generally function for outlier detection. Do not offer such clear representations of relations between features and classes in the dataset. Yields representations of boundaries, more than generative. Do not allow one to generate samples from the joint distribution of observed and target variables. Generates lower asymptotic errors. Generative AI. Requires less training samples. Model the distribution of individual classes. Provides a model of how the data is actually generated. Learn the underlying structure of the data. Have discriminative properties. Make some kind of structure assumptions on your model. Decision boundary, where one model becomes more likely. Often outperform discriminative models on smaller datasets because their generative assumptions place some structure on your model that prevent overfitting. Natural use of unlabeled data. Takes all data into consideration, which could result in slower processing as a disadvantage. Generally function for outlier detection. Typically specified as probabilistic graphical models, which offer rich representations of the independence relations in the dataset. More straightforward to detect distribution changes and update a generative model. Takes the joint probability and predicts the most possible known label. Typically more flexible in expressing dependencies in complex learning tasks. A flexible framework that could easily cooperate with other needs of the application. Results in higher asymptotic errors faster. Training method usually requires multiple numerical optimization techniques. Will need the combination of multiple subtasks for solving complex real-world problem. Difference between pre-trained models AI and LLM, large language models. Pre-trained models. A pre-trained AI model is a deep learning model, an expression of a brain-like neural algorithm that finds patterns or makes predictions based on data that's trained on large datasets to accomplish a specific task. It can be used as is or further fine-tuned to fit an application's specific needs. LLM, large language models. A large language model, LLM, is a type of artificial intelligence, AI, program that can recognize and generate text, among other tasks. LLMs are trained on huge sets of data, hence the name, large. LLMs are built on machine learning. Specifically, a type of neural network called a transformer model. In simpler terms, an LLM is a computer program that has been fed enough examples to be able to recognize and interpret human language or other types of complex data. Many LLMs are trained on data that has been gathered from the internet, thousands or millions of gigabytes worth of text. But the quality of the samples impacts how well LLMs will learn natural language, so in LLMs programmers may use a more curated dataset. LLMs use a type of machine learning called deep learning in order to understand how characters, words, and sentences function together. Deep learning involves the probabilistic analysis of unstructured data, which eventually enables the deep learning model to recognize distinctions between pieces of content without human intervention. LLMs are then further trained via tuning, They are fine-tuned or prompt-tuned to the particular task that the programmer wants them to do, such as interpreting questions and generating responses, or translating text from one language to another. What is prompt engineering? Prompt engineering is a relatively new discipline for developing and optimizing prompts to efficiently use language models, LMs, for a wide variety of applications and research topics. Prompt engineering skills help to better understand the capabilities and limitations of large language models, LLMs. Researchers use prompt engineering to improve the capacity of LLMs on a wide range of common and complex tasks such as question answering and arithmetic reasoning. Developers use prompt engineering to design robust and effective prompting techniques that interface with LLMs and other tools. Prompt engineering is not just about designing and developing prompts. It encompasses a wide range of skills and techniques that are useful for interacting and developing with LLMs. It's an important skill to interface, build with, and understand capabilities of LLMs. You can use prompt engineering to improve safety of LLMs and build new capabilities like augmenting LLMs with domain knowledge and external tools. Thanks for watching.